Welcome to 7.1 Law of Sines. We are going to start today with the derivation of the law of sines. Chapter 7, we will study the law of sines and the law of cosines, which takes trigonometric functions and applies them to non-right triangles. So remember that all of our trigonometric functions in their pure form only apply to right triangles. However, we now will have the law of sines and the law of cosines to be able to solve triangles that are not just right triangles. Let's look at triangle ABC, which is not a right triangle. First, I will label the sides. If this is point A, then the side opposite needs to be side A. Notice we use uppercase letters for the angles or the vertices of the triangles and lowercase letters for the sides. So opposite angle B will be side B and opposite angle C will be side C. Now, if I want to find trigonometric values, I need a right triangle. So what I will do is draw a line from point B perpendicular to AC, and this will actually be the height of this triangle with base AC. So now, using this, go ahead and push pause and try and find what is the sine of A and what is the sine of C. So the sine of A, we have to use this right triangle. We use this left side of the triangle. So sine of A is opposite over hypotenuse, or H over C. Similarly, sine of C, now we will use the right triangle on the right-hand side, and sine of C is opposite over hypotenuse, and that's going to be H over A. So now we have a lot of unknowns, but what do you notice these two equations have in common? They both have H in common. So what we could do is solve each of these for H. On the left, I will multiply both sides by C. So C sine A equals H. On the right, I will multiply both sides by A. So now I have C sine A equals H and A sine C equals H. Since both of these quantities equal H, they must equal each other. C sine A equals A sine C. Now, to get this in the form that we want it in, we will divide both sides by AC. On the left, the C's cancel, and we are just left with sine A over A. On the right, the A's cancel, and we are left with sine of C over C. So this gives us one version of our law of sines, which states that sine A over A equals sine C over C. And notice that A, B, and C are all interchangeable. The law of sines applies to any pair of angles and sides, as long as those angle and sides are opposite each other. If we wanted, we could also write this as A over sine A equals C over sine C. Let's go ahead and apply the law of sines. Example 1. Solve the triangle. A equals 28.8 degrees. Angle C equals 102.6 degrees, and side C equals 25.3 inches. In order to solve any triangle, it means that we must find all three angles and all three sides. I like to list out all of them so I make sure that I get all of the components. This is not necessary, it's just a way to organize the work. I just inputted what we have, and now we can see we need to find angle B and sides A and B. I like to draw a picture, but this is not necessary. Since we have two angles of our triangle, we can find the third angle since all three angles must add up to 180 degrees. Therefore, B plus 28.8 plus 102.6 must equal 180. Adding these two together, we get B plus 131.4 equals 180. Now we subtract 131.4 from both sides. Therefore, angle B equals 48.6 degrees. Now we need to find side A or side B. And this is where we want to use our law of sines. Since we are looking for little a, I'm going to put little a up top, and then that will go over sine A. And now I need an angle and a side that are opposite each other where we have both of those numbers. So I'm going to use C because we have side C and angle C. So C over sine C. Now we're going to plug in the information we have. So we get A over sine of 28.8 degrees equals 25.3 over sine of 102.6 degrees. In order to solve for A, we could either cross multiply or simply multiply both sides by sine of 28.8 degrees. I'll go ahead and cross multiply, but you are welcome to just multiply by sine of 28.8 and then make that calculation. If we cross multiply, we get A times sine of 102.6 equals 25.3 sine of 28.8. And now to solve for A, we divide both sides by sine of 102.6. Now we're going to plug that quantity directly into the calculator. 25.3 sine 28.8 divided by sine of 102.6, and make sure you are in degree mode. This calculation gives us A equals 12.5. And since this is the side of the triangle, the units of little c, or the units of any side, will determine the units of our missing sides. So our side A is 12.5 inches. Now, it might be tempting to find the third side of this triangle using Pythagorean theorem, but do not do that. You could pause and try and figure out why not, but the reason why we cannot use Pythagorean theorem is this is not a right triangle, so Pythagorean theorem does not apply. To find little b, we need to use the law of sines again. I will write b over sine b equals c over sine c. Even though we now have angle A and side A. We found side A by using this calculation, so really it was just an estimate. Therefore, I'm going to use angle C and side C, since both of those were given, in order to avoid any accumulated rounding error. Plugging in the numbers, we get B over sine of 48.6 equals 25.3 over sine of 102.6. Notice the right-hand side ended up being exactly the same. I will show you the other method now of solving, which is multiplying both sides by the sine of 48.6. Since my b is on top, I have that luxury. Of course, if you prefer to cross multiply, that is still an option. If the variable you're looking for is not on the top, cross multiplication is definitely the way to go. So on the left, sine of 48.6 cancels, and on the right we are left with 25.3 sine of 48.6, all divided by sine of 102.6. Now we're going to put that into the calculator. Rounding to the nearest tenth, we get 19.4, and again, our units are inches. One quick check is to make sure that the biggest angle is opposite the biggest side, and the smallest angle is opposite the smallest side. While this does not guarantee our answers, at least it verifies that our answers make sense. So we have solved this triangle by finding all three angles and all three sides. I hope you enjoyed this video. See you next time.